G'day guys, we've got a question today where it's asking us to take the quotient of two imaginary numbers. What we've got is we've got 6 plus 3i in the numerator and 10 plus 8i in the denominator. And we're being asked to present this as just one complex number. In doing this, what we're probably going to be able to do as well is investigate some of the properties of the complex conjugate. Now, just reminding you guys what the complex conjugate is if we have a complex number, z, which is equal to a plus bi, its complex conjugate is equal to a minus bi. So basically we change the sign of the coefficient of the complex or the imaginary part of this number. Cool. So the way that we're going to, I would say, exploit the complex conjugate to solve this question is we're going to use it to remove the imaginary part of the denominator. Now, how are you going to do that? Well, if I have this, let me just rewrite it down here. 6 plus 3i in the numerator, and I've got 10 plus 8i in the denominator. If I multiply this by 1, but not just any form of 1, I'm going to multiply this by the complex conjugate of the denominator. So the complex conjugate of this is going to be 10 minus 8i. But to make it equal to 1, so that it doesn't change our fraction, I have to put it over itself, 10 minus 8i. So you can see here, this is the equivalent of just multiplying it all by 1. Now, what is this going to actually do? Well, let's make it easier for us to multiply out. We'll rewrite it, but in brackets. So we've got 6 plus 3i multiplied by 10 minus 8i. And then we have 10 plus 8i. Minus 8i. Now, I'm doing this the long way so you guys can get a feel of every single step that I'm sort of doing. So where do we go from here? Well, like exactly how we would multiply out a quadratic or a binomial expansion. Some people like to call it the FOIL method. So I'm going to go 6 times 10, and that's equal to 60. First outside, then we have 6 times negative 8i, which is going to be minus 48i. Then we have inside 3i times 10, which is, so it's going to be plus 30i. And then last, we've got 3i times negative 8i. So 3 eighths are 24, so it's negative 24i squared. Cool. And that's all divided by, now you can see that this is a difference of perfect squares on the bottom, but we'll multiply it out just for your benefit. So we've got 10 times 10 is 100. Then first outside, 10 times minus 8i is minus 80i. Then we have 8i times 10, so we have plus 80i. And then we have 8 plus 8i times minus 8i is minus 64i squared. Cool. So why did I do all of that working out for you? So what we can do is in the denominator, we can combine those middle two like terms and they will add to equal 0. In the numerator, let's have a look at what we've got. We've got 60 and we've got this 24i squared. Now I is the square root of negative 1. So if we square that, it's just going to equal negative 1. So negative 24 times negative 1 is plus 24. So in the numerator, we've got 60 plus 24, which is 84. And we have negative 48i plus 30i is negative 18i minus 18i. We're going to put that over 100. Then we've got minus 64i squared. Now like this, we've got I squared, which is negative 1. Minus 64 times negative 1 is plus 64. So we've got 100 plus 64 is 164. Great, so we've just removed the imaginary part of our number, of our complex number, in the denominator. But we still can, we need to present this in a form that looks like this. So let's go about doing that. We can just break up the two numbers in the numerator and just make this 84 over 164. So that's your A. Then we have minus 18 over 164 I. Now obviously we're going to simplify that. So we've got 84 over 64, divide them both by 2, we get, what's that, 42 over 82. We can divide them by 2 again, so we're going to have 21 over 41. Minus 18 over 164 divided by 2 is 9 over 82, and that's as far as we can go. Cool. So what we can then say is, you can say, therefore, 6 plus 3i over 10 plus 8i is equal to 21 over 41 minus 9 over 82i. Cool. So what did we learn from this little question? Well, what we learnt is that by multiplying by the complex conjugate in both the numerator and the denominator has the same effect as multiplying the entire fraction by 1. But what it does do is it eliminates the imaginary part of the complex number in the denominator. So once we've eliminated the imaginary part of the complex number in the denominator, we can then split the denominator over the two sections of the numerator and then simplify. Once we've simplified by just finding common factors in both numerator and denominator in both fractions, once we've simplified, we come out with a nice answer at the end. So it's not a complicated question, guys, but it does require a knowledge of how the complex conjugate works and the properties of the complex conjugate. And also, guys, I know it's simple, but just ensure that you know that the square root of the I squared is negative 1, and because of this property up here. But I hope the video helped, guys. If it did, give it a like, subscribe to my channel. It does help me out a fair bit. And if I put out new videos all the time, and if you'd like to ask me any questions, it gives me new ideas for videos, so I'd be happy to solve them. So until next time, guys, have fun.